With the shape controllers in place, you are now ready to rig the spine. This includes the three bones that make the actual spine, but also the pelvis, neck, and head bones. You start with the pelvis bone. Go ahead and select it. From the animation menu, choose Constraints, Orientation Constraint. A rubber band appears. Click the hip controller object, the one you set up with a darker blue color and made it into a wavy shape. Because both objects are oriented the same way, nothing happens just yet. However, as of this moment, rotating the shape controller has a direct effect on the hip bone. Mind you, this effect is usually used in small amounts for small rocking actions, or simply shifting from side to side. It does help making simple motions like a walk cycle much more believable, though. Select the pelvis one more time. In the motion panel, switch to the rotation section if you're not already there. Notice how a new orientation constraint track has been added to the list controller and has been set to react to the hip shape. Take note of the Keep Initial Offset option. At this moment it doesn't do anything, but you'll be able to experiment with this in a moment. Repeat the procedure to constrain the orientation of the base spine to the spine base controller. When this is done, try to local rotate the shape and see the effect it has on the upper body. That's fine, but you need more control between the upper part and the lower part of the spine. You want to be able to affect the spine base independently, or at least with a minimal effect on the shoulders. Select the third spine bone and constrain its orientation to the neck base controller. With that, you'd have a more natural control as to how the bottom and the top of the spine are behaving. Because the spine isn't perfectly vertical, twisting the base induces a slight shift at the top, but that's normal. Otherwise, you have a nice independent control over the top and bottom parts of the spine. The problem at this time, of course, is with the middle bone. At this stage, it is simply following its parent. This is why it seems so rigidly attached to the spine base bone. The trick is to weight it to balance itself between the bottom and top of the spine. Select the middle bone and constrain its orientation to the hip shape. Doing that, you'll notice a snap of the bone as it reorients itself in the viewport. The reason this happened is because the initial orientation of that bone is not the same as the orientation of the controller. This is where the Keep Initial Offset option comes in. Using that option, you ensure the bone stays in its original state, although it is now constrained to the controller. Still, at this point, not much has changed. The middle bone now follows the controller rather than the parent bone. Since the parent bone is also following that controller, the effect is the same as before. Select the middle bone again. In the motion panel, notice that you can add other orientation targets. Click the Add Orientation Target button and then select the neck controller. Click Add Orientation Target again to disable that mode. You now have two targets for the bone to follow. By default, the weight is distributed evenly between them. You can see the effect as you rotate the controllers in various axes. If the spine were made of 4 or more bones, all middle bones would need to be constrained to the hip and neck base controllers. The weighting would have been different, with the lower bones favoring the hip controller and the upper bones favoring the neck controller. As an example, if you had a 4-bone spine instead of 3, the second bone would be weighted 66.6 33.3% in favor of the hip controller. The third bone would be weighted 66.6 33.3% in favor of the torso or neck controller. You'll fine-tune the spine in a second. First, let's take a look at the head and neck. Select the head bone and constrain its orientation to the head controller. That's easy and straightforward. Now do the same for the neck bone and constrain it to the neck base. Not bad, but the neck bone should also respond to the head rotation. In the motion panel, add the head controller as an orientation target. Remember to disable that mode when you're done with it. This gives you a much more natural neck behavior as you manipulate the controllers. The rig is coming together, but you can improve on it yet. Select the hip controller and rotate it locally on its x-axis. This makes the pelvis bone twist affect the thigh bones as well. However, as the pelvis twists, the lower spine should be slightly affected as well. You can always counter the effect by rotating the spine-based controller, but here's another way. You won't be using orientation constraints in this case. The pelvis and the spine bones and their respective controllers are not aligned the same way, and this would be problematic. Instead, you will wire rotation axes between the spine-based bone and the hip controller. This way, you'll be able to control exactly how much of a rotation ratio is happening between the two objects. Select the spine-based bone, spine 1, and go to the motion panel. In the rotation panel, notice the rotation list as it stands so far. There are 3 tracks, with the third being the orientation constraint. Expand the assigned controller rollout and the rotation list. Select the available track and add yet another Euler XYZ controller to that list. With this done, right-click the bone in the viewport and choose Wire Parameters, Transform, Rotation, Euler XYZ, X Rotation. Notice that you need to select the X rotation of the newly added Euler XYZ track, not the original one on top. With the rubber band display, click the hip controller and link to its X rotation track. The parameter wiring dialog appears. You want the hip controller shape to control the twisting of the bone, so make sure you're set in a right to left direction. Click the Connect button. Try to rotate the hip controller on its local x-axis. As the controller rotates to one side, the bone rotates to the other. Add a negative sign to the expression and click Update. Try it again. This time, the bone rotates correctly, but needs to be toned down to rotate less than the controller. Add a divide by 2/2 to the expression, and click Update again. Test it again. This is working much better now. If you wish, you can repeat the procedure with the middle spine bone for a better twist effect. This time, you need to divide the expression by a higher value of about 3 or 4 to have the spine bone rotate even less. Finally, when you're done, you should be able to control the upper body fairly well. Play around by rotating the various controllers, but make sure you select them and set their transforms to 0 before moving on. In the next movie, you move up to rig the arms.